think I might have just started the video. So okay. Welcome to statistics. No, so what I was just commenting was that it seems this should be the last lecture. Okay. The only thing that I have after that is the practice for the final exam. All right. So we'll talk about that, I guess, in a little bit, probably at the end or something like that. What do you guys want to do? All right. So you still have to obviously complete your exam 5 and the final, right? The final, I don't remember what the date is. We'll talk about that also, but the final is listed on there when you have to come and take it. But the only thing you're gonna have to do really is complete the content that's online and then complete the final exam. And that's the remaining stuff that's left. Does that make sense? So, all right, let us see what we have here. We did this one before. 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 All right, so this thing. What is the difference between this stuff and the last stuff we were working on? So just read this question, please. And then what would you say the difference is here, if you want? Fractionize is not a word again. Fractionize. Oh, damn it. Fractionize. I'm gonna fractionize you. Read the damn question. Come on. What's the difference? Please. Yo, we're over here doing this. Come on. So good. What's the question? Answer my question. What's the difference between this question and the last ones? Read the question. I'm not asking you what to do. I'm just saying, what is the difference between these questions and all the last ones we were doing? No, we definitely have done stuff with significance levels. We never compared two proportions. That's true, but there's kind of more than that. Well, I mean, what do the two proportions have to do with? Like, where are they coming from? The sample? Huh? I mean, read the question. What is it saying here? Equalize? I know that's a word. They're trying to equalize? What the hell are you talking about? It says something about like age 20 to 24, age 20 to 25. I mean, 25 to 29, right? They're not equaling. They're not equal. The point is there's two samples here, not one. Does that make sense? I don't know why we shouldn't be able to say that though. Does that make sense? there's two proportions because there's two samples now. There's two groups. We're comparing two different things. Yes? All right. So, um, let's just go through a little review of some of the stuff that we were doing so far with this hypothesis testing. Sorry, just one second. Why are you hiding over there? That's what I figured. Oh, come on, bro. Now let's see if it actually works. Hey, look at that. All right. So then, what was I talking about? So if we have a mean, then we said those means would be normally distributed with some mean and some standard deviation. If the original distribution has a mean and standard deviation, right? And then this is only when n is greater than 30 or the question says like approximately normal or something. Does that make sense? Then we said then like z is going to equal to whatever, like x bar minus the mean divided by whatever the standard deviation is, right? Then if sigma is unknown, what distribution does it use then? T is correct. Then we say this is T distributed with some mean. And then we have to use the degrees of freedom also, right? That it would have to be, someone would say something like, it would have to be approximately normal though. Because the central limit theorem doesn't apply. So then we would say T is going to equal to X bar minus the mean divided by S over square root of N. And I guess we might as well write out the confidence interval stuff also. The margin of error, if it was a mean, then the margin of error would be like Z alpha over 2 star times sigma over square root of N. T would be what? T alpha over 2 star times S over square root of N, I guess. Then we did some stuff with proportions. So we said P hat would be approximately normal with mean P, standard deviation, square root of PQ over N. Then we said that PQ and where's PQ? NP, excuse me, and NQ need to be greater than or equal to 10, I think your book says. Then Z is equal to X bar minus X bar. Z is equal to P hat minus P all over square root of PQ over N. Now, if you don't know what the mean is and you were constructing a confidence interval about the sample proportion, though, then we would start saying that this would be Z alpha over 2 star times square root of P hat Q hat over N, because we don't actually know what those are yet. All right, any question about any of those first? Does that make sense, though? And just remember that the margin of error, the way I'm writing it here, this first part is really just number of standard deviations away from the mean times the value of the standard deviation, right? Does that make sense? Does that make sense, guys? Test statistic is number of standard deviations. All right. Well, now we got to start talking about this new situation. We'll do this stuff with 2 samples. Okay? Any question about any of this stuff? All right. So what's the difference now? We'll come back to there in a second. Okay? Because I'm going to have to fill in some more stuff. All right. So what's the difference now, though? Well, you got 2 groups. Okay. So we were talking about this. I mean, this to me is like sort of like the reason why, someone brings up any of this crap, right? I keep talking about previously, like someone with racism or something like that, comparing 2 groups, and then one group is not necessarily treated the same way as the other group, right? And like, how would you identify this? Does that make sense? Right? Or you have 2 schools and they say one school is better than the other school, right? And I want to look based off of the students' test scores to take the tests, right? There's a group of people taking tests at one place, a group of people taking tests at the other place. We have to compare. Does that make sense? Right? So we got 2 groups, right? So I guess let's talk about proportions first, because we talked about proportions first before, I think. No, actually, I want to do means first. Means make more sense anyway. Okay, so the difference now is that when you're talking about your ho and your ha, not my ho. So then no, when you're talking about the ho and the ha, right? Ho means what? Null hypothesis, and then HA is the alternative, right? And what did I say like alternative means? No. I mean, they do have to be like complements of each other, these 2 things, but they're not necessarily opposite. Is the alternative. But what did I say when we're reading the question? Say one more time. Not exactly. Maybe, but that's not the right word. What you want to prove. Why are you doing the test? That's what you want to show. Does that make sense? Okay. Not necessarily expect. Does that make sense? Say again? A hypothesis, yeah. But I'm saying like if I start saying I think the people are gonna be taller than what everybody else is saying, right? Then I want to show that they're taller, right? So my hypothesis then is that they're taller, right? But that's what I want to show. Is that correct? All right. So then but this is the alternative, right? I'm just reminding you what each one means. Does that make sense? Okay. So then the difference now is though that like they'll start writing hypotheses like something like this, where we'll say like, well, the mean of the first group, we're gonna have to assume that the two groups are actually equal to each other. Does that make sense? So you have these two schools, right? And you want to start saying that the one school is not as good or something as the other one, right? And then, you know, let's assume they're actually the same. Does that make sense? And then let's give them a test. And then when the one school does worse than the other one, we'll look at the differences between these results. Does that make sense? And if the number is too large, maybe that shouldn't have happened. Does that make sense? And if it did happen, maybe us assuming that the two things were equal would let us show that they actually shouldn't be equal. Does that make sense? Or that the difference between these two results really could not recur just by random chance because it was too different. There's too many people that took the tests, and there's too many people at this school that did worse than the other school. Does that make sense? Not just by random chance, not just, oh, you didn't show up today. Oh, you just had some bad teacher at that school this year, right? Does that make sense? All right, so what do I want to prove? Well, we're going to be able to show what the mean of the first one is either going to be, or we're going to try to show that one's bigger, one's smaller, and then one's not equal to. Does that make sense? Does that make sense? So almost the same as before. Is that right? The only thing is that I find that if you do this little algebra that I'm about to do, it sometimes gets helpful to do a lot of these questions. So I'm just going to subtract mu2 from both sides. And then this original statement is equivalent to saying this statement. So like this one and this one are the same. If you say one is equal to the other one, well, then one minus the other one should be 0. Is that right? But sometimes this helps, right? We'll see when we start doing some of the questions, okay? And it's going to help to understand what we even need to do here, right? So I'm just going to rewrite all of these things that way also. Something like that. Does that make sense? All right, well, if we're talking about these means, then really now the problem is that we do not have really one group anymore. We have two groups. Does that make sense? So sort of like there's going to be some group one that you're comparing to group two. You're going to end up getting a sample of some size from the first one. Does that make sense? And then you're going to get a sample of some size from the second one. All right. So I'm just going to refer to them though as x1 bar and x2 bar. Does that make sense? Each of these individual groups would have some sort of mean and standard deviation and whatever. But if they're not that different from each other, well, then the schools really aren't that different, right? All right, but we want to compare these two things. So if this number n1 happens to be sufficiently large or larger than 30, the central limit theorem would apply, and then the distribution of these sample averages would have to follow a normal distribution or be approximately equal to a normal distribution. Does that make sense? Okay. So then the thing is that, and likewise for this one, okay? So then what we're going to say is now that we have to make some sort of assumption here that we want these things to be normal. So that means that we're going to hope that n1 here is going to have to be greater than 30. And then n2 is going to have to be greater than 30. Or they're going to have to tell us in the question that these things are normal. Does that make sense? Does that make sense? All right. So then if they do that, this is the thing that I kind of want to talk about here. That like mu1 minus mu2 is supposed to be equal to 0. The mean from the first group minus the mean from the second group. Does that make sense? But that means we're taking like the number from the first one and the number from the second one, and we're kind of subtracting them, and they're coming from two different distributions possibly. Does that make sense? All right, but we can actually talk about that also. So if x1 is normal, because if this is greater than 30, x1 bar would be normal. Does that make sense? So it's normal. And then let's assume there's some mean associated with it. And then let's assume that there's some standard deviation associated with it, or some sigma 1 over square root of n1. And let's say x2 then, bar, would also be normal because we said that n2 was going to be greater than 30. And of course, you have to, someone mentioned earlier that, these things need to be randomly selected. That's true. Okay. But that doesn't tell me much of the story. Okay. That's the first step, and it has to happen. Otherwise, you're biasing your sample and you're not really going to come up with a good result. But that's not, we're assuming that for these questions. Does that make sense? All right. So the x bar 2 is normal. And then let's say there could be some mean and then some standard deviation. All right. Well, the thing is that in the first step here, we're always assuming I said that the mean of the first group is going to equal to the mean of the second group. Does that make sense? So that means I don't really need to write mu1 and mu2 here. Does everybody see that? Does that make sense? We're going to assume they're the same anyway. Okay. In reality, they're probably not. But if they're not that different from each other, it doesn't really matter. Okay. Does that make sense? All right. So here, really, since we are assuming mu1 is going to equal to mu2, we can just write mu, I guess. Does that make sense? Okay. Or you don't have to write it that way. You can write it this way also if you want to think about it that way. It doesn't matter. All right. Now, the thing is though, the difference here as compared to some of the previous stuff is that we're now talking about the difference between two distributions. Now, that's kind of weird if you think about it. Like, that's kind of like not very simple because, like, if I randomly selected a student that's in that building over there, and then we randomly selected a student that's in this building over here, like one time it could be crazy boy over here, and then it could be someone completely normal over there. What? Why are you someone talking about you? Anyway, so like no, one time it could be just like God knows who, right? Over here, and then someone over there, and it's like all these different like pairs you would have to think, and it's like, I don't know, there's a lot of combinations that are possible. Does that make sense? And then it's like if I start saying like the amount of money that you have compared to the average amount of money, or the amount of money that person has, right? And we start subtracting those things, it's like we're going to get a different answer for all these different pairs, and it's, I don't know, it's a lot of numbers. Does that make sense? So, but that's why we did a bunch of those formulas before, and some of them can actually help solve some of these things. Okay, so now we have to make another assumption. So the first assumption was that these are randomly selected, right? You said black people can turn into white people. Boy, you crazy. Anybody was here that day? Raise your hand if he said black people can turn into white people.
Did not say those exact words precisely.
There's like 5 people that were just shaking their head yes.
No, I'm not saying.
And I don't even know if anybody else was here that day. So then like
We had a whole lot of connection. People in punishment, if you woke up, you know, a lot of, especially on the days. That is being crazy. That is being discriminated. Father.
No, I'm joking. All right, so then all right, these things need to be randomly selected, but then they also need to be independently selected from each other also. In other words, what I'm saying here is that the way you're selecting the things from the first group cannot influence the way you're selecting anything from the second group. It's not like this guy, this is like a guy, and then this is his wife, or this is the wife, and then that's the guy. No, they're not like matching up in any way, shape, or form. It's just some random group people from one group, some random group people from another group. Does that make sense? All right, of a particular size. Okay, you said black fishing. I don't want to talk about this. This sounds bad. All right, so then all right, let's finish this first. You're scaring me right now. All right, so then scare me a lot of times. All right, so then we got x1 bar, x2 bar, right? Now the thing is that if these things are randomly selected and independently selected as well, right? Or the selection process is independent with respect to the two groups, okay? Then what's going to happen here is that we're actually more looking at now the distribution of x bar 1 minus x bar 2. So we need to start talking about how to combine these two things, okay? Now, I'm not going to prove in this class that it turns out that if the first one's normal and the second one's normal, then if you add or subtract them together, they're also going to be normal, okay? But it turns out they are. And if you try to think about that you can make sense of in your head a little bit. Does that make sense? By just thinking about the shapes of the distributions and like thinking about numbers that would come from them and how often they would come and stuff like that. Okay. But turns out that if you subtract these two things and they satisfy the conditions and they're normal, right? Then the difference, or actually any linear combination supposedly also works. So if you start doing like a times x1 bar plus or minus b times x2 bar or something like that, if they're both normal, then this will also be normal. Okay. All right. And then the thing is we can start saying something about what the mean and the standard deviation is going to be also. All right. So that's what I'm going into here. So x1 bar, x2 bar, they're going to be normal. The mean is going to be just mu1 minus mu2. The standard deviation is going to be a little different. We got to work that out a little bit. Does that make sense? All right. Now, if you, well, what did I just do? If you recall from previous, we said something like this, that the variance of one group or one variable, excuse me, random variable, plus or minus the other random variable is going to actually equal to the variance of the first random variable plus the variance. Is that color bad? You like that mood lighting. You like that. It's okay. You smile. Smile. Okay, don't smile. So then the variance of the first group plus the variance of the second group. But the thing is that the two things do need to, the random variables need to be independent from each other. Does that make sense? All right, so that's why I was mentioning this condition earlier here, that they need to be independent. Does that make sense? Sampling process, okay? So then if this is true, so really all we have to do is just take the variance of the first one and add to the variance of the second. Does that make sense? All right. Sometimes people write this instead like this. They'll say like sigma squared of x plus or minus y. Again, if the random variables are independent from each other, is going to equal to sigma squared of x plus sigma squared of y. Now this thing kind of reminds me here of, like c squared equals to a squared plus b squared, or the Pythagorean theorem. Does that make sense? It's sort of like you got one part and another part, and they're like perpendicular to each other. They kind of don't have anything to do with each other. Does that make sense? And then you start trying to combine them together, and then it's going to be bigger than both of them. Does that make sense? All right. But this is the formula. Does that make sense? And we worked this out previously. I'm just rewriting a different way. All right. So then if we want to talk about x bar 1 minus x bar 2, right? Well, all I said here was, so the first thing I said was like, oh, if I do the expectation of this variable minus this variable, it's going to be the mean of this minus the mean of this. Does that make sense? that make sense? Right, this is the same thing here as the expectation of x bar 1 minus x bar 2. Does that make sense? All right. So now here we need to do this variance thing. So whatever, let's just write that out real quick. So variance of x bar 1 minus x bar 2. Okay, well then that would have to be, since these are independent, the variance of x bar 1 plus the variance of x bar 2. They get bigger. Does that make sense? Right? So that means the variance of this one minus this one is going to equal to, what's the variance of the first one? Say again? That's the standard deviation. So that squared is correct. So that's sigma 1 squared over n1. You square it, the square root goes away. Is that right? Does that make sense? Plus then the other one's going to be, I guess, sigma 2 squared over n2. Does that make sense? Does everybody understand what I'm saying? Then if I wanted to find the standard deviation, we would have to take the square root, I guess, of both sides. So we take the square root of this side, we take the square root of that side. Does that make sense? Right, if you want to get rid of the square, is that correct? Does that make sense? All right, so then we end up getting sigma of x1 bar minus x2 bar is going to equal to the square root of whatever this stuff is I just wrote here. n1 plus n2. Does that make sense? All right, well then that's what goes over here. This is whatever this thing is. And we're going to do this again for proportions in a second. Does that make sense? But it's going to be the exact same process, just with the different variables for that standard deviation. Because this formula always works. Does that make sense? You get what I mean by this? Do you understand what I'm saying? I'm adding the two variances together. That one of them, the variation of one group, the variation of the other group. When you add, so here, let's just do just a reminder example that we did before a long time ago. Does that make sense? But I don't think we really used it very much, so I probably should have not done it then. All right. But I needed it to prove some of the other things, so that's why I was doing it at that time. But I ask this dumb question all the time, but I feel like it actually helps you think about why I'm adding the two things. Does that make sense? All right, so I said something like this. I said, like, if the first dude comes in and has somewhere between $0 and $100 as anywhere between those two things, right? And then the second person comes in and they have between $0 and $100, right? I don't know if you remember this example. Okay. Then I said something like, well, what would we be able to have if it was we're adding the two things? Now we both come in, we have something between 0 and 100. Is that right? Well, how much would we have together then? How much could we have? What's the minimum we could have? What's the maximum? 0 and 200 is correct. Does that make sense? And then if we have like, if we subtract them though, this is the part that I find a little bit strange. All right. So if you subtract them, what's the minimum you can have? Negative 100. That's correct. What's the maximum? 100. Because you could have 100, I could have 0. Does that make sense? Does that make sense? The amount of variation between, so I'm not proving this to you either, but it turns out that the way that so if we assume that this first thing has this uniform distribution between 0 and 100, right? Then turns out, I mean, I could do it, but it's a lot more math, okay? But this one is going to be then between 0 and 200, but it sort of starts looking like a triangle then. Okay. Right, because it's going to be really hard for both of us to come in with 0. It's going to be really hard for both of us to come in with 100. Is that correct? But actually, it's kind of easy for us to come in with something around 50. Because I could bring 75, you could bring 25, you could bring 75, I could bring 25, right? We could both bring 50. Is that correct? It's like a lot of ways it can happen. Does that make sense? All right. So then this happens more often. Does that make sense? And if you did this, if you kept adding these things, actually it would start eventually looking like a normal distribution. Does that make sense? All right. But the point of what I'm trying to say here is, though, that the thing I think that's a little bit unexpected. Oh, so this one's going to look like this. This one's going to look like this. The one we subtract. Does that make sense? But this is negative 100, and that's 100 right there. And the point that's interesting with these types of things is that in this case, the distributions are identical to each other, but the point is shifted, right? But the point is that it's not always going to be like that, but they're going to have the exact same amount of variation. Does that make sense? The spread. Does that make sense what I'm saying? Okay. And that's what this formula is really saying. Does that make sense? That all I'm really doing is adding the two variations of the individual groups in some way together. But then, to get the standard deviation, you have to take the square root. Does that make sense? So that's why they call it the variance, because the variance is sort of more important with all of the formulas and stuff like that. But the problem is that when you have some data set, right, and I collect all of these x's, and x's, let's say, are heights or something. So this is like meters, right? Standard deviation is also in meters. The mean, the standard deviation is in meters. Does that make sense? But the variance is the variable squared. So the variance ends up being meters squared. Does that make sense? So that's why they don't talk about it all the time, because you can't relate it back to the original numbers so easily. Does that make sense? So that's why we have standard deviation. All right. But the variance is sort of more important. Okay. Mathematically, I guess I should say. All right. Anyway, so we have this distribution. Does that make sense? Okay, let's go back over to this thing. So that means if we started subtracting, yikes, let's not start. Should we use a different color? I don't know if I really like this pink anyway. Pretty in pink. You like green better? I like green better too, actually. So then this X bar, what are you smiling about? I'm joking. So then this X bar 1 minus X bar 2, right? So if we take these two things and we start subtracting, or really if we started adding them, okay, we can start saying what the distribution would be for both of them. But we're usually going to start subtracting if we're comparing two groups. I want to see if one's bigger than the other one or whatever, right? So then this is going to mean that it's also going to be normal, all right? Now the only thing is that when is it going to be normal? Well, N1 is going to have to be greater than 30, and N2 is going to have to be greater than 30. By the way, all of this one is in your book also, and they write almost the exact same table. Does that make sense? So this is this. Then the mean of this thing is going to be mu1 minus mu2. Is that right? Mean of the first group minus the mean of the second group. Does that make sense? But we could even start testing something like, I could start saying like, your parents have more money than you. And they say on average, they have this much more money, whatever it is. Does that make sense? But it's obviously not going to be true for everybody. So we start sampling, in some cases it's going to be true, in some cases not. Is that right? So maybe you start assuming that the mean difference between the two things is, I don't know, 10,000 or whatever it is. Does that make sense? Maybe you assume, but most of the time we're going to be assuming it's 0. We're going to be assuming that the two groups are equal to each other. Does that make sense? All right, the standard deviation, maybe I should have left myself a little more space here, is going to equal to sigma 1 squared over N1 plus sigma 2 squared over N2. Does that make sense? All right. Then if it's normal, we would be able to use Z distribution. this is gonna mean, we take the mean of the first group minus the mean of the second group, that's the sample thing. Minus, then we would have to use the mean of the first distribution minus the mean of the second distribution. We wanna see how far the average distance that we observed is compared to the average difference of the actual distribution. Does that make sense? Does that make sense? Just remember, this is always, the left thing here is always sample, the right thing here is always the parameter. Does that make sense? The parameter is that. Is that correct? Does that make sense? All right, so then we have to divide by whatever the standard deviation is. So I just end up copying whatever this nonsense is we just wrote. Again, the thing is that the standard deviation changes for the different distributions. Is that right? Does that make sense? If we were going to construct a confidence interval, it would be what? Z alpha over 2 star times the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. Does that make sense? Any questions so far? All right, then we could also, I guess, not know sigmas. It's extremely unlikely for us to actually know sigma of both groups. Does that make sense? So in most cases, actually, you're not going to use that. You're going to end up having to do a t distribution. You all right? X bar 1 minus X bar 2. We're going to have to use t in that case. Does that make sense? Does that make sense? Then it's going to be mu1 minus mu2. The standard deviation is going to be S1 squared over N1 plus S2 squared over N2. The degrees of freedom is slightly different. Degrees of freedom, we're going to take the minimum of N1 minus 1 and N2 minus 1. So we take the minimum degrees of freedom of the two groups. Because we want to, like, if your school, they sampled 50 people, in my school, they sampled 20 people, right? Like, my group's going to have more variation. Does that make sense? But there's a better way to calculate it, but they don't make you do it in this class. Your calculator does it for you, actually. Okay. But the simplest way to think about it is this, that you can't take the variation to be like what your variation is, because your variation is going to be very small. So we started taking the variation to try and make it more like what mine is, so that we can account for the possibility of large changes. Does that make sense? All right. So then this, again, the assumptions need to be really that N1 is greater than 30 and N2 is greater than 30, or again, they state that they're both approximately normal. This stupid thing is going to be almost the exact same thing. X bar 1 minus X bar 2 minus mu1 minus mu2 all over S1 squared over N1 plus S2 squared over N2. This is going to be T alpha over 2 star for the degrees of freedom. And then this is going to be S1 squared over N1 plus S2 squared over N2. Now, the thing is though, most of the time, if the null hypothesis is mu1 minus mu2 is equal to 0, or excuse me, mu1 is equal to mu2, which is the same thing as saying mu1 minus mu2 is equal to 0, right? if we assume that, which we're gonna do a lot, then this part and this part would have to be 0. Is that correct? Does that make sense? Then this and this would also be 0. Does that make sense? Most of the time they're 0. Okay. Question? It could either be that it doesn't equal 0, it's less than 0, or greater than 0. Does that make sense? Same thing, right? Say it one time. Pretty much, because otherwise we're allowing the same thing as what the hypothesis is. It can't be like that. Does that make sense? What are we going to test that? What are you proving? You know what I mean? Hey, it's different from 0 a lot of times, but sometimes it's the same. Okay, what did you tell me then? Does that make sense? All right, so now we got to do something with proportions a little bit. So proportions, now if we have two groups of proportions, so we're going to again assume P1 equals to P2, which is the same thing as saying P1 minus P2 is equal to 0. P1, we could be trying to prove it's greater than P2. Like the percentage of people that voted for Trump is higher than the percentage of people that voted for Hillary or whatever. Does that make sense? Right? That's literally how they do the election stuff when you're sitting there. And then, I mean, do you know at the end of the day, like how elections work or not? So they have the votes, right? Then what happens? Like, how does the election end? How do you get electoral points? How do you decide who gets those points though? So let's say I'm against you. Let's say I'm against. They never really get to that. They never really get to that. They never really get to that. It's decided well before that ever happens, that anybody ever counts all those votes. It's always decided well before that ever happens, except for the 2000 election with Bush and Gore, was it? That was the only one that was ever decided a different way. As far in recent history, at least, I don't know what happened a long time before that necessarily. But the okay, so you and me are running against each other. All right. No, my ass is gonna win. So then you fail. So then no, but you and me were running against each other. All right. All right. People don't like me. Okay. Stop shaking your head so fast. So then so people don't like me. You know, we're running this election. We're getting now, it's like 7 p.m. at night or whatever. We counted a bunch of votes from some places, but the precincts have only reported, let's say, about 12 to 20% of the votes. Okay. Oh, that's a sample. Right? Okay, so then you're kicking my ass though. You got like 70% of the votes. I got like 10. Yeah. So you have like 7 times as many as I got. Does that make sense? Now, what's going to start happening is that we can keep counting more votes. Okay. But there's a certain point where there's a certain difference that's going to exist that we observe, right? Where I start saying like, yo, man, you don't got to bother. Like, let's just stop now. You win. And that's generally how it stops. Does that make sense? So usually what'll happen is that you'll see all these things on TV and they'll start recording all these votes or whatever. And they'll start saying, oh, you know, so-and-so has 60% or 40% or 48, and the other one has 47 or whatever the hell it is, right? And they keep counting and counting and counting and counting and counting and counting. And then effectively they construct confidence intervals associated with both of the two estimates. And then they start seeing if those confidence intervals are going to overlap or not. And if those confidence intervals don't overlap anymore, Then I start coming to you and I'm like, yo, man, I won. It's time. It's time to call it. So then you come and you turn around and you're like, I don't want to waste anybody's time anymore. I appreciate everybody coming here. You guys really, we did a good thing. We really came really close, but at the same time, unfortunately, we didn't make it. And don't worry, we'll kick his ass next year, right? And then but the state then awards the electoral votes in whatever manner they do it. All right. Now, if it's proportional voting, which is in some of the states, then they wait until the end to determine most of this. But honestly, once you start getting to like 40% precincts reporting, if they're even close, the candidates, you probably can already tell who's going to win. Does that make sense? But if you're really close, you have to ask everybody. But that's rarely happened. Does that make sense? Question? Some states were closer, but the problem is like Trump was playing this nonsense card that that it was fixed, that they weren't counting the votes properly and all that. That's bullshit. Okay, so like the thing that goes wrong in this country is that people don't let people vote. That you want to talk about something racist or not correct and stuff like that. That's the thing that's not correct. But or you could make an argument, let's say, okay. But when you start telling me that they weren't counting the votes correctly, like there was no evidence to ever support anything like that. And that is a claim that's made many times in countries where governments are not very strong, and then you can overthrow the government by doing that. So then that's what kind of he was trying to do, and that's nonsense. Okay, so that election, you can't even talk about this thing with this guy, like this bullshit. Okay, but the the Gore one, like Florida was so damn close. Oh, and then also, if you think about this, also, this is another thing that's bad. Okay, so they start counting the votes, right? You and I are close, all right? Like literally, like let's say there's 10 million people. You're gonna end. Oh, let's say not 10 million. Let's say 9,999,999. You're gonna end up with 500,000 people in the state like you, 499,000, or excuse me, 5 million people in the state like you, 4,000,000.9999 whatever like me. Does that make sense? All right. So we have an election. Depending on who shows up that day, we don't know who's going to win. You could win one time. I'm going to win the next time. Does that make sense? Depending on who decides to vote, right? Because it's that close. Does that make sense? You understand? All right. But now let's say we have to count the votes. So people fuck up, right? When they count, right? I do. I've never seen a person who doesn't. All right. People mess up with their counting all the time. Okay. So then what's going to happen? And what actually happened? So when they're doing this election counting in 2000, they were sitting there and they start counting these boxes, these ballots and all this crap, and the ones that were done through a machine and all this nonsense, right? And the absentee votes and the military votes and this votes and those votes and all this nonsense, right? And I'm counting them, or excuse me, there's a Democrat and a Republican counting each one of them, supposed to be, okay? They get different numbers. And they count again. They count again. And they count again. Okay. And then they find out that there's a box over there that nobody counted. And then they find out that there's all these votes over here in this one place that nobody counted. And then people start getting suspicious. Well, how do you find these votes? Right. And then the Democrats find some votes, and the Republicans find some votes. And then the Democrats find some votes, and the Republicans find some votes. And that's what kept happening. Okay. Because if you and I sit here and count 5 million pieces of paper, we're going to get different answers, right? Right? So that's what kept happening, okay? And then one time you're winning, one time I'm winning. Well, the problem is in reality, it's too close. Does that make sense? There is no decisive candidate, so that's the reason why that starts happening when you have an election, because the confidence intervals would start overlapping. Does that make sense? All right. Nothing. More important to have an elect, the more important to have a transition in government. You just pick somebody. Does that make sense? So then so you just let it go. It's like, oh, we got you, you win. Oh shit. We messed up. Okay, sorry. Derek wins, right? Oh, we messed up again. No, I was right the first time. Okay. And that's it, we're done. Stuff like that. Okay, so then all right, so um P1 could be greater than P2, which would mean that P1, oops, how do we get to pink? P1 minus P2 would be greater than 0. Then, of course, we could say P1 is less than P2. We could say P1 is not equal to P2. Same type of stuff. Any question so far? All right, then you do. Sorry, my bad. Uh-oh. He really won the election? I never heard him say that. I don't know. I gotta tell you, like, a lot of things people say, like, I just don't care. Like, I'm not gonna listen. I gotta tell you, I don't really care anything about Kanye. Kanye's dumb. I would like to beat up Kanye. That would be fun. But sorry? Yeah, but he's still a pussy. Anyway, so stupid. On what? Oh, who cares, bro? These candidates, they both talk so much shit all the time. But that guy, he's like his thing is to talk shit. Like that's how he does stuff. You know what I mean? And then he people like it, so that's all he does. But all right. So then, if the group 1 and the group 2, they're going to end up giving you a estimated proportion, some number sampled, and some number of successes, possibly. Does that make sense? Then, or you're gonna have to figure that out. Then, if the expected number of successes and the expected number of failures is greater than or equal to 10 now for both groups, then we can start assuming that each group actually starts following a normal distribution. So then P1 hat would follow a normal distribution with mean P1, standard deviation, square root P1, Q1 over N1. And P2 hat would follow a normal distribution with mean P2 square root of P2 Q2 over N2. Then P1 minus P2 would also be normal by the same reasoning as previous. The mean would be P1 minus P2. Standard deviation would be equal to so if we square these things, effectively the square roots just go away. Does that make sense? So it's just P1 Q1 over N1, P2 Q2 over N2. So then that's the square of the standard deviation. So the standard deviation then would just be square root of all this stuff. P1 Q1 over N1 plus P2 Q2 over N2. Does that make sense? Now, sometimes people do it the way I'm saying it here. And sometimes people do it with this thing called pooling. So if we talk about the pooled standard deviation, we talk about the pooled success rate. So we can define this thing called P bar to equal to x1 plus x2 all over n1 plus n2. What would this mean? You have two groups, you're given this stuff here. What would this mean? Why would you do this? Proportion, like how though? What is it? Explain what this means. Like what is x1 plus x2? Not means. Mean is x1, means bar. No. What is it when you're doing proportion? What does x mean? What does p hat mean? Estimated proportion, proportion from the sample. That's correct. What does that mean? Like what does x mean when we're doing that? What do we say x was? How do you calculate this p1 then? Hat. X over n, number of successes. X is the number of successes, right? So this is the number of successes from the first group. This is the number of successes from the second group. This is the sample size from the first group. This is the sample size from the second group. What is it? What is this calculating? Yeah. Combined. Divided by. So it's like you got the two schools. We check how many people are passing in the one place. We check how many people are passing the other place. We add all of it up. We add up all the people we were looking at. Does that make sense? It's like the overall proportion when we combine the two schools, when we pool them together. Does that make sense? Anyway, so sometimes they'll do this. Does that make sense? All right. Then this formula would change slightly. Okay. Then they would start writing this square root of p bar q bar over n1 plus p bar q bar over n2. Does that make sense? This is if we're assuming that that this would be a better estimate for the overall proportion of the underlying distribution. Does that make sense? Question so far with any of this? Does it make sense? Okay. So this should look similar, all right? So now we come back over to this thing and we finish this crap. So now if we start talking about P1 hat minus P2 hat, or did I not write it over here? I should have probably, no, I did, I wrote it already, right? Or if we're doing a hypothesis test, we're going to talk about P1 minus P2. And this would end up being normally distributed if N P1 comma N Q1 would be greater than or equal to 10 and excuse me, not N, it should be N1. N1 P1 comma N1 Q1, and then it would be N2 P2 comma N2 Q2. That would also have to be greater than or equal to 10. Then this would be normally distributed. Normal distribution would have mean P1 minus P2. The standard deviation would be square root of P1 Q1 over N1 plus P2 Q2 over N2. Z would equal to P1 hat minus P2 hat minus P1 minus P2 all over square root of P1 Q1 over N1 plus P2 Q2 over N2. The confidence interval would be Z alpha over 2 star times the square root of P1 Q1 over N1 plus P2 Q2 over N2. Does that make sense? One thing, just want to remind you real quick. If you go to formulas and tables, formulas and tables, formulas and tables, and then if you go to test statistics, oh, look, it's the same bullshit we just wrote. Oh, test statistics, two proportions. Oh, look, it's the same bullshit we just wrote. Does everybody see that? It's all over your book. Okay? Libra? That was a weird noise. All right, so then this, any question here? You got me? Lately. What's up with this thing, man? I hate it when it does this. Wake up, bro. I see you. I was just joking. All right. I guess I don't really want to, but it's not right if I don't do it. So I will write it all out again. Okay, to do this. Does that make sense? With the 4-step process and all that stuff. Does that make sense? All right. So then let's start moving. All right. And then we'll do all the rest of them with the calculator. Okay. All right. So what's the first step? We might as well calculate some proportions here. So P1, this is what? N1. This is X1. P1 hat is what? 11 over 50 is what? 22%. Then this is N1, 2, sorry. And this is X2. So this means P2 hat, what is this? 63 over 450 is what? 50 is 9 is 50, and this is 7.14 is correct. So then this is this. Table below shows the smokers a random sample of 500 adults, age 2024, number of smokers, sample 450, age 2020. Assuming significance level of 10%, test the claim P1 is not equal to P2. Okay. So then we do step 1. So then our ho and our ha. The ha is mu1 is not equal to mu2. Does that make sense? The ho then is mu1 equals mu2. And of course, I just said there's a lot of times that I feel like it's better to write it this way to make sense out of some of the stuff. Okay. And we're going to do the confidence interval also. Okay. That second way is going to be better for the confidence interval. All right. We have to verify statistics here or whatever. So we have to check expected number of successes, expected number of failures, right? So N1 P1 is 110 here. N1 Q1 then is 390 or whatever. So those are both greater than or equal to 10. N2 P2 is 63. N2 PQ2 is 45 minus 60, 450 minus 63, but that's definitely greater than or equal to 10 also. So then we have those two things. Does that make sense? So great, they're normal. Does that make sense? All right, so then since they're normal, we would assume that the mean for P1 is going to be this, and the mean for P2 is going to be this because we have nothing else. Does that make sense? So then we need to calculate a test statistic. So then we're thinking like that there's this distribution that we want to do then that's going to be P1. What do we want to do? Yeah, P1 minus P2. That's going to be normal with the mean equal to whatever P1 minus P2 is. And then the standard deviation, because we really don't know. Does that make sense? And the standard deviation is going to be square root of P1 Q1 over N1 plus P2 Q2 over N2. Does that make sense? But we don't have this stuff. So we're going to have to use the sample values. Does that make sense? All right. So then the test statistic we got to do, right? So we start thinking about this normal distribution. But we're assuming that, oh, I'm sorry. I wrote mean here, but that makes absolutely no sense. I started doing proportion everywhere, but I wrote mean here for some reason. It should have been, excuse me, P1 equals to P2, because this is a proportion question. P1 minus P2 is equal to 0. And then it should have been P1 is not equal to P2. It even said it in the question here. I don't know what the hell I was writing. P1 minus P2 is not equal to 0. Does that make sense? All right, so that was stupid. That was really bad. But you see, I'm getting to a point, and it's like it makes no sense whatsoever. Does that make sense? If you can't notice that, yeah, you do deserve to get it wrong. All right. So then so wait a second though. This means we're assuming that P1 minus P2 is 0. So then this is 0. Okay, so that's a little easier. Does that make sense? All right, so 0 is here, right? Assume the proportions are the same. Look at the observed difference. See if the observed difference is actually significant. Does that make sense? All right, so then what is the observed difference? Well, what is it? Sorry? No, that's alpha. What is the observed difference? That's so 8%, right? So then this of course would mean like P1 hat minus P2 hat is 8%, right? So that's what we observed. Is that right? So we have to start seeing like how crazy that is. Does that make sense? Okay, so then Z is going to equal to whatever I said before. P1 hat minus P2 hat minus P1 minus P2 all over square root of P1 Q1 over N1 plus P2 Q2 over N2. Does that make sense? But again, we don't have this crap, so we're gonna have to use the hats. Right? Or if you don't like that, you would come up with a pool proportion for both of them. Does that make sense? Which means you would just add this stuff. Overall proportion. Does that make sense? But the thing is like, I don't really like doing that because if you're assuming that the two things are coming from two completely different groups, or you want to prove they're coming from two different groups, why are we assuming that we're going to combine them? Does that make sense? At the beginning, like it's kind of like not the right way to think about it, sort of. But it depends on whether how trustworthy, how many data points you have, and all that kind of stuff. Maybe you combine them just because you think that there'll be less variation. So that's a lot of people do this. Does that make sense? All right. So then this part again though is 0. Does that make sense? So then we have P1 hat minus P2 hat. Okay, well, that's 8%, right? Then this bullshit. So then this is P1 hat. Great, that's that, 0.22. Q1, that's 0.78. N1, that's 500. This thing's 14% times 86% all over 450 or whatever. Does that make sense? Question? Move. So then the question? All right, let's see what this number is. Because we should calculate some numbers. You can leave your phone over there. Sorry? I didn't stop. What are you talking about? They're still on there. What do you mean? All the videos are on YouTube. What are you talking about? Huh? Oh, the last one because it didn't record the audio. I told you. So then this, but I put other ones on there. So then 0.08 divided by square root of 0.22. Sorry about that. That pissed me off actually. That other video was good. The one we did in class that day. The one without audio. But I redid it. I did the same stuff anyway, so they're still on there. All right. So then this, whatever this garbage is, that number, I guess. Does that make sense? Let me just make sure I typed it correctly. Oh, this stupid thing won't even let me see it. 0.22, 0.78, 500, 0.14, 0.86, 450. Yeah, it looks fine. Okay. So whatever this garbage is, approximately 3.2371 standard deviations to the right. That's a lot. Does that make sense? Okery dokery. Now we have to calculate that area right there in step 3. We need the p-value. So the p-value in this case is just the area of that particular region. So that would be normal CDF. Excuse me. This is a two-sided test, right? Since it's two-sided, when we do p-value, we have to double it because it could occur on the other side just as likely. Does that make sense? Right? We really didn't know which side it should be on at all. So if it happens on this side, it really could just happen on that side. Does that make sense? So we sort of kind of imagine something here. We're just like, oh, that one too. Does that make sense? So the p-value in this case is going to be 2 times normal CDF of the z-value to 1e99 because we have to find that area. Does that make sense? That value. Is that right? Let's see what that is. 2 times normal CDF. Oh, piece of shit. Ah, I tricked you. Okay, so then this is still here. Okay, so then this is the right number. This is right. I'm just going to delete those two because I never really write them anyway. Does that make sense? We get this. Okay. Pretty small. Is that right? So I got that this was approximately equal to 0.0012, I guess. Does everybody see that? All right, then the last step. We have to draw some sort of conclusion now, right? So then the p-value is definitely less than alpha in this case, right? 0.0012 is definitely less than 10%. this would then imply that we reject Leho. Reject the null hypothesis. Does that make sense? So then we would say that there is sufficient evidence to suggest you don't really reject the hoe. You just start saying you accept the alternative, or you start saying it supports the alternative. So there is sufficient evidence to support the claim that the proportion of smokers in the age 20 to 24 group is different from that of the proportion of smokers in the age 25 to 29 group. Does that make sense? I actually find that like doing it with two samples actually makes more sense. Like I feel like this actually starts explaining why we're doing some of this stuff. Does that make sense? Question? Let me make this smaller. All right. Any question there? All right. Now, I guess we might as well do it on the calculator. No, let's do confidence interval first. So then so we do the same thing using the confidence interval method. Then again, the null hypothesis and alternative are still the same from before. We sketch our normal distribution to start trying to say what size confidence interval we need to select because we need to pick the right size. So then in this case, the confidence interval that we would need to select would be this area over here and this one over here, because it's two-sided, have to equal to 10%. So then the middle part would be 90. Does that make sense? So we do a 90% confidence interval. I don't know if I want to write all of that out again. But effectively, it would be this standard deviation, right? Does that make sense? So like that standard deviation times Z alpha over 2, which would be what? Inv norm of 0.95. Does that make sense? Times whatever that number is, and that would end up giving you the margin of error. Actually, whatever. Let me just do it on the calculator because I don't feel like writing out the values right now. But I just wrote the standard deviation here, didn't I? Oh no, I wrote this crap instead. Come on, bro. Don't do that. All right, this thing, this. Flip it over times 0.08. That should be the standard deviation. Does that look right? Yeah, that looks right. Okay. So then, oh no, this is 0.8 now. Shit. Sorry, that number should be the standard deviation. Does that make sense? This number is the standard deviation. Now I'm just going to take that and multiply it by inv norm of 0.95. Second? For which? I just did this stuff here. 500, 450. So then this number would be the margin of error, I think. Does that make sense? Unless I just made a mistake calculating something, typing something in. But anyway, let's see. I don't know if I trust what I just did actually. Actually, I'm just gonna write it. I'll do the whole thing again. All right, so square root of 0.22 times 0.78 divided by 500 plus 0.14 times 0.86. I don't know why I was whining about this. This took like 2 seconds. All right, so then that number, right? That times, now we have to talk about how many standard deviations we have to go away. So I was doing inv norm of 0.95. Again, we don't need any of this crap. So we get that. Does that make sense? Now the observed difference between the two proportions was 22% minus 14%. So then we would have to add and subtract this to this value. Does that make sense? Well, I guess it looks like we're getting this. Does that make sense? But that doesn't say the proportions should be equal to each other. It says we're between 3.9% and 12%, right? All right, let's make sure that I didn't make a mistake just now. I feel like I just made a mistake. All right, so when we do test, two proportion z test, x1 in this case is 110, n1 is 500, x2 was 63, n2 is 450. We said not equal to. I got a slightly different answer here, which is not so great. Because they're using the pooled proportion. Does that make sense? Does that make sense? I can recalculate it with that, but really it's very close anyway. Does that make sense? So I got 0.001, 0.001. Does everybody see that? All right. But if I recalculate it using this, we'll get the exact same answer. Okay. Mm-hmm. All right. Then the thing is that because the pooled proportion is more conservative, so that's why they're doing it. All right. I just don't like it because it's like, I don't know, it's kind of a bad assumption. But so the p-value here, we would still reject. Does that make sense? All right, now I'm gonna get a slightly different answer when we're doing this also, because pooled standard deviation versus regular standard deviation. Does that make sense? So then this, if we do two proportion z interval, this is all here. 90% is correct. You get this? Again, those are almost the exact same numbers we were just saying. Is that correct? I can't believe how long I just took to do this. There's like 2 more things we still need to do. I usually do all of this in an hour and 15 minutes. And so far I've done one part of it. Anyway, this then is saying then P1 minus P2, we think is between 0.03935 and 0.12065. Now, if the null hypothesis is that the difference between these two things is 0, right? Like that doesn't look like that says 0. Does that make sense? So there's significant evidence to say that they're different. Does that make sense? Question with this? Question? All right. Let's see what else we got here. That's the claim that the proportion of women favoring stricter gun control is higher than that of men. The proportion of women is greater than the proportion of men. Does that make sense? Oh, sorry. This should be equals. I meant to write the alternative first. This should be greater than this, right? All right. So, I mean, you just type it in pretty much. So, stat one prop Z test. Whoops. One prop. Stat two prop Z test, excuse me. X1. What do I write for X1? No. Very good. 65% times the 360. Is that right? N1 is 360 though. Does that make sense? Jaden, does that make sense? X2 then is 220 times the 60%. Is that right? N2 is 220. We're testing greater. Is that right? Does that make sense? We get this. So what does this mean? What do these results mean? Okay, that's correct. So then what do we do? Say again. So what is it? You never really accept though. You either reject or you fail to reject. Fail to reject is correct. All right, the p-value is too large in this case. It's bigger than that. Does that make sense? Right? So in this case, we would say that the proportion, test the claim that this is happening? No, there's not sufficient evidence that the proportion of women favoring stricter gun control is higher than the proportion of men favoring stricter gun control. Does that make sense? P-value is too big, not lower. All right. Question? Not rare enough. Does that make sense? We can do a confidence interval here also. So if we were going to do a confidence interval, then this part would be 5% here, right? The confidence interval would be what size? 90 again. Is that right? This thing gave us all the numbers already. It copied it for me. This part again, you might have to change, but we just got lucky. It was the same. Does that make sense? So we get this. This again confirms the exact same result because this is saying now the null hypothesis is assuming that PW minus PM is 0, right? So now this is a confidence interval that's now saying between $90. This is between here and here, right? Sorry? No. This is between here and here. That means that this still could definitely be 0. Is that right? So 0 is contained within the confidence. Is that correct? So that means we still think that could happen. Is that right? So I can't reject the null hypothesis then. Is that right? So there's not sufficient evidence in this case. Again, it's the same conclusion though. Does that make sense? Does everybody understand how to state the conclusion? It's based off the null hypothesis. So it depends on what the number is here. Does that make sense? Because like, what if I was testing to see if you had $50 or not, right? Then this would have to see if 50 is contained in here, right? Right. Well, because then you can't reject the null hypo, right? That's the whole. That's why I'm saying that kind of makes more sense to people. You understand what I'm saying? This part, right? That's why you see them give you those types of statistics when in the newspapers and whatever. Does that make sense? Like the margin of error type stuff. Okay. Question? All right, so I guess let's stop there because this now gets into a whole different thing. What do I do? Yeah. I mean, I could do this part, but nah, let's just stop there. That's fine. Okay. So then we'll have one more lecture, I guess, and then we'll have zero review for the final. Okay. No,